Hello guys, demo time again. So now today I'm gonna demo the new plugins. Again, a new plugins for NC Sender. So let's start with uh, also there's a new updates on the NC Sender. Now you don't need to go to the GitHub to install the plugin. On the install plugin, there's already a repo registry where you can uh, download what's available plugin. So for this demo, I'm gonna show you the ToolBench, install it. And then what it does is it will register 3 additional tools, which I think these are most commonly used, a very quick way of generating G-code. So the idea is you don't need to go to your CAM like Fusion 360 or Batrix to generate a simple G-code command. For example, you just want to do a surfacing or the planar, or you just want to do a cut, like a straight cut. I use this a lot on aluminum where I don't have a chop saw. So we can do that on the uh, jointer or cutter. And then another one that I added recently is the boring. So if you wanna cut a hole, either you want to make a circle, or you wanna make a hole on your material. So either way, there's a in and so I'm gonna do the planar, which is basically just a surfacing. If you're using a G sander, there's a surfacing. So this one is just a planar. So what I'm gonna do is I'm gonna measure this as a demo. This is 75 millimeter by, ooh, oh, my caliper is not, it's only up to 150. So let's do this one by 190 millimeter. I'm using metric. I'm used to use metric, not imperial. So 170. So what I'm gonna do is let's enter the dimension. So our X is 190. So I'm gonna use the keyboard so it's easy to type instead of a virtual keyboard. So that's 190. Well, make it 200. And then 75, or let's just make it 80. Then depth of cut, I only wanna do maybe 2. And then target depth, maybe 0.4, so it's 2 pass. Step over is 80%. Let's just do 60%. Then the bit I'm gonna use is 1-inch surfacing bit. My feed rate is maybe 1,500 for now. RPM is 1500. Delay, I don't need a delay because my alt mill support at speed. So meaning you don't need a static delay. The controller itself will wait for the spindle to reach its speed before processing the next command. That's what the at speed is for. Then we click the generate code. Then we have a surfacing. It's there, but we're gonna use this one, the auto zero. So I'm gonna do a probe. I'm gonna auto zero touch so you can see the drawing. So our bit diameter is auto. Let's just say auto, and then that's it. The thing will. So let's refine it. So the beauty of this is the jog is already there on the probe window. So you don't need to go to the. This is the first time I'm gonna use this, by the way. So someone donated this probe so I can program it. I guess that's, well, it's not even. Okay, so let's do X, Y, and Z. Corner is right. And then, okay, we need to, usually just use this to contact it. There you go. Let's do it. I don't know if it's gonna work. It's the first time I'm gonna use this. Up. Okay, looks so good. So far, so good. Okay, now get our machine. We're gonna load our. I'm gonna long press the T7 because that's where my surfacing bit is. I need to twist my surfacing bit because it's blocking the infrared. So it's gonna. Okay. So now I think we're ready. All we need to do is just, because I don't want to be messy, I'm gonna attach my Autodesk boot. We'll set the height. That's good. Double tap it. And then let's connect the. Okay. And then let's run it. Oh, vacuum is auto on. Okay. Did I actually generate with. Um, oh, okay. I need to turn the coolant generate again. Should be the same. Just gonna turn on the coolant. Good thing I checked. Although I can turn on again. So let's do it. That's weird. It didn't turn on my vacuum. Oh, I picked the mist, not the flood. Okay, the issue is why it's too high. That's still too high, so let's pause it. I'm gonna stop. And actually, let me actually regenerate again with the flood. Generate again. Okay, that's done. And then let me inspect that. Then I'm gonna lower my Z. Let's just inspect if my Z is actually 0. According to this, okay, yeah, so 0.6, 0.65. Yep, that's too high. So that's the reason it didn't. So I need to adjust the programming of this because this is static number. Because I use my clone one. This is one, which is, I guess they have a different thickness. Oh yeah, they have a different thickness. That's the reason. I think this I program it using my clone one versus this, the original Auto Zero touch plate, which I think might be more than 5 millimeter. Yeah, okay. But it's not the problem. So let me just manually, I guess we're gonna do the good old fashioned eyeballing. Okay, that's 0. We'll zero it, raise it. Okay, we're good. Oops, let's run it again. This should start surfacing now. There you go. Looks good. I'm gonna do the boring, and I'm gonna do a 50 millimeter hole. 50, and then I'm gonna do inner, and then our bit is 6.35. I'm just gonna do maybe 3 millimeter pitch depth of cut. So we wanna cut till 34, 34, 34 millimeter. So I'll make it 34.2. Depth of cut. Oh, sorry, that's oops. Oh, forgot to save it. Dang it. Maybe I need to convert this to a dialogue. So 34.2. Well, I'm typing on the pitch. I'm gonna do 3 millimeter pitch. 32.4. And then I only need the 50 millimeter. So I only need to do one hole. You can also multiple hole. But on this demo, I'm just gonna do one. And 6.35. Bid rate is 3000. RPM is, let me just, this is 15 R. And then I want to do a coolant plug generate. And then let's auto fit. Spindle view. Auto fit. Oh, sorry. Model's too small. Okay, let's connect this one. Oh, actually, I forgot. So I'm gonna lower it. Again, I'm just gonna eyeball it for now. Because we need to move the center. Okay, that's probably good enough. I'm gonna do XY there. And connect. Oops. That's probably good. I think I might, let me reduce the bid rate because I'm not sure if this is too aggressive. We can just adjust the bid rate anyway on the fly. Generate. And then let's see if the height is good. Let's lower it because we already cut more. And run it. Where are we? Where's the spindle? There you go. Oh, it's almost cut. Almost cut it. There's a few more left. So we're gonna do more. Did I put it right? 34.2. Let's make it 35. Oh, I put 32.4. It's 34.2. Why I keep clicking? 34.2. Generate. Then let's run again. There you go. We have a hole. Let's raise. And then let's move away. Okay, here. So we were able to cut the hole without even going to any cam. So we don't need the simple job like this. So if you want to do planer or surfacing, jointer, if you don't have a jointer or cutting, like a metal cutting, like aluminum, you can use that tools. It's very handy. Because I found sometimes I use this like, oh, I need a circle. Look at this. There's something wrong on my G code that they need to modify because it has like a lead in. So I might need to remove that. So you can, well, it's not a problem for inner, I guess, or for, because let's actually do some cutting. So I'd say 50 millimeter. So probably this one. Oh, there you go. 49.80, 49.9. There you go. So pretty good. That's point 0.1 difference or on out of spec on my target, which is, I think it's really good for yeah, it's 49.95. So actually it's zero point 0.05 out of target. 0.05 millimeter, not that, that's not inch, that's a millimeter. Okay,